Hey everyone, I thought I'd jump in and do some reviewing. This is a worksheet that I just searched online and I found. It was for an integrated algebra. It's 4-3 exponential growth and decay. So it's not one that I made, but it's one that I found online. I thought it'd be a useful review. So I wanted to start by going back and reviewing some exponential growth and decay with you. The first thing we're going to talk about is a reminder of the multiplier. So again, this is a review. The lessons have already been taught. So if you feel like you've missed something, you might need to go back to the lessons. But we want to start with talking about our multiplier. And we are given a percent, whether it's growth or decay. So a quick reminder is if it is growth, we are always starting at 100%, and we are going to add a percent to that. If it is decay, we are still, again, starting with 100% of our population, initial amount, and then we are going to take away what's being decreased or what is descending, whatever is going down, and we want to know what's remaining. So with growth, we're adding to it. We have 100% of our population plus more. With decay, we had 100%, we took some away. We want to know what's left over. So if we lose 25%, we're keeping 75%. And then the multiplier is always going to be given as a decimal. So I like to keep it in the percent, just so it's easier to deal with the decimals. So I have 100% plus 5%. So I get 105%. But when I go to put this in my equation, I'm going to use my multiplier as 1.05. And this makes sense because 1, we multiply by 1, it gives me back my number. And then a little bit more, so 1.5%. 12% decay, I'm losing it, so it's going to be 100% minus 12%. Okay, so that gives me 88%, which is a decimal of 0.88. So decay should always be between 0 and 1. All right, now I have 200% growth here. And so if you really think about 200% growth, some people want to look at it and say, hey, it's doubling, and it is. Our growth is not just doubling. If it's growing by 200%, it's 200% above what we have. So we're going to start with our 100 plus 200%, and we're looking at a 300% here. And that actually makes my multiplier 3. So we want to be careful because we say doubling. If we say something's doubling, we're going to do a multiplier of 2, but it is growing. All right, now I see this 0.85% decay. And as much as I like to not rely on a calculator, I need you to think about this. It's 100% minus 0.85. That's less than 1%. So if I put this up there, I'm going to take 100 minus 0.85, and I get 99.15. Remember, if I was taking away 1%, I'd have 99% left. And so I want to make sure that real careful that it's 99.15%, which makes it a decimal 0.9915. Okay, so that's my multiplier. Now, the next set of questions is asking us whether the following is growth or decay. How do I know if it's growth or decay? I am looking for the multiplier, and that's what we were just talking about. So is my multiplier, if my multiplier is greater than 1, not equal to, but greater than 1, then I have growth. If my multiplier is from 0 is less than my multiplier, I'll put m for multiplier, which is less than 1, then I have decay. Okay, next thing, how do I know what my multiplier is? My multiplier is my base. It's not the first number or the second number or number in parentheses. It's the base of my variable exponent. So 3 is my base, so I know this is growth. It is tripling. 0.25 is my base, which is the same as 1/4, and so that's between 0 and 1. I'm losing something. I'm decaying. Now, just something interesting here. 0.25 is what's remaining. That means I must be losing 75% and have 25% left over. Okay, this is just greater than 1, and so it is growth. And what am I growing by? Well, I have 100% plus 1%. I'm growing by 1%. This one is very small. It's 0.033, and because it's between 0 and 1, I have decay here. All right, and now this is where we're going to get to problems like 9 and 10, where we have a number out front, like 6 would be my initial amount, and then 5 is my multiplier to the power of x. So this might be the initial amount times 5 to the power of x. 5 is my base though, and that means that we have growth. And here I have 6 times 1/2. 1/2 is my base, and so I have decay. I'm losing 1/2. All right, we have some other problems that have this breakdown here. They say to identify the information and then solve. So we have movie tickets are $9.75 a ticket, and they're increasing by 15% per year. How much will they cost 5 years from now? Okay, so we're looking at an exponential growth. So it is growth. And what is my multiplier? Well, since it's growing, it's going to be 100% plus 15, which is 115%, which is 1.15. All right, is 9.75 your zero term or your first term? I know that's confusing because a lot of people want to say it's your first term. It's your initial amount. And so to get 9.75 back, I'd actually have it to the power of 0 on my multiplier. So I'm going to explain here that it is my zero term, and then let me show you why. What is my explicit expression? Okay, so the amounts over time, I'm going to use t, I'm going to use this in function notation, is my initial amount of 9.75 to my multiplier of 1.15 to the power of time. And in our case, the time is 5 years. Now, it's important that it's growing per year, and we're talking 5 years. So it's the power of 5. Okay, so when I was talking about being the zero term, I would write it as 9.75 times 1.15, and the power has to be 0, because 1.15 to the 0 is 1, and I get my 9.75, my initial amount. So it is like term 0. Okay. No way am I solving this in my head, so I am just typing it in my calculator now that I've got that, times 1.15 to the power of 5. And I'll make sure you can see that. So it's there. It's 9.75 times 1.15 to the power of 5, and we get 19.61. And yeah, I'm just going to keep it rounded to the nearest penny, so it'd be $19.61 in 5 years. So yep, there's definitely a lot of growth. $9.75 to $19.61. Okay, so we have another problem here. A company is purchased for $2,000, but it is losing 20% of its value each year. What will it be worth in 4 years? Okay. I think I said a company, a computer. All right. So is this growth or decay? Well, it's losing it, so it is decay. What is my multiplier? The mistake is a lot of people want to put 0.2, but we always have to start with 100%, and we're losing 20. That means every year I keep 80% of this computer's value. So my multiplier is 0.80. We always want that in decimal form. Is 2,000 your zero term or your first term? 2,000 is my initial term, so it is my zero term. And that's because we need that power of 0 on the multiplier, so we keep that 2,000. What is my explicit? What is my equation? Explicit meaning what defines this relationship. So the amount over time is equal to the initial amount of 2,000 times 0.80 to the power of time, and we're talking in 4 years. So we would put a power of 4 there. Okay, and again, I'm going to use my calculator. I'm typing in my 2,000, and we could use parentheses or the time symbol, times 0.8 or 0.80 to the power of 4, and I get $819.20. So when am I ever going to use this math? The question we all hear, if you are an insurance adjuster, you are certainly going to use this math. This is called like a straight line depreciation. So if you have a computer that's 4 years old, you're not going to get the full value of it back if it's lost or broken and you're claiming it with insurance. So there is that idea, and we know that because we think about car insurance all the time, and your car value depreciates, and your insurance is not going to give you what you paid for the car. They're going to give what your car is worth at that time. That also includes wear and tear, mileage, what type of car it is. Okay, so just thought that was interesting. We have some other problems here. So dinner at your grandfather's favorite restaurant now costs $25.22 and has been increasing 4% per year. How much did it cost him 35 years ago? Okay, so this one is a little bit different, and we have to think backwards for it. So